Here we're going to look at a little bit of a harder problem with sums and with a double angle. It really gives us a workout with unit circle stuff and also these formulas in a way that some of the other more basic problems doesn't. So we have a mystery angle U and a mystery angle V. And what we know about U is we know its sine, and it's 12/13, and that's chosen to be relatively nice. And we know the cosine of V, and we know that that's 4/5. Just knowing those two numbers alone would not tell us exactly where those are on the unit circle, but I'm going to tell you that U is in quadrant 2 and V is in quadrant 4. The task is to find the cosine of U plus V, or separately to find the tangent of 2U. So the picture here, I've got it on Sketchpad. So U is some mystery angle that's in quadrant 2 and whose oops, let me take this down a little bit. There we go. Whose y-coordinate is 12/13, so that's about 0.93-ish. And V is a mystery angle in quadrant 4, whose x-coordinate, the cosine, is 4/5 or 0.8. So there's the picture. And it's really nice to have some very, very rough sketch picture. Really just getting it, knowing that U is in quadrant 2 and is relatively high, 12/13 is close to 1, and that V is in quadrant 4 and is kind of somewhat over to the right, because 4/5 is moderately close to 1. That's a nice picture to have. Okay. But what we know is that if we could know all of these four quantities, then we'd be good. This is the use of the cosine sum formula. If we just knew these four together, then we're good. Okay, so the key is that we really need to do a previous kind of problem, which is given the sine of this angle, what is the cosine of this angle? And given the cosine of this guy, what is the sine of it? And that's really review stuff, but people tend to get flustered here with the addition of the cosine sum formula. Okay, so it's really important. We're not going to take like 12/13 and put it into a cosine. That's not what we're going to be doing. We're going to find these numbers, and they're all going to be fractions. We're going to use Pythagoras to find those guys, and then we're just going to assemble it with this. Okay, so I'll put a little dot 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 because I'm not quite ready to use that. What I do know is that cosine U, okay, let's see, cosine U, if we look at the picture, that 12/13, that fits into a little right triangle. Let's see if I can draw it quickly enough. I'm going to do a perpendicular. Okay, so here's a triangle where this guy, this is the unit circle, so that's 1. That's 12/13, and we have to figure out what this guy is as well. Okay, well, that's going to be, let's call it x, and we know that x squared plus 12/13 squared equals 1, or x squared plus 144 over 169. And if you recognize that 12 and 13, you might be able to get it easier than this. X squared is 169 minus 144 over 169. Aha, that's equal to 25 over 169. And usually in these problems, it's going to be a nice Pythagorean triple. Now, there's a plus or minus that I should put here, except that's where we use it. It's in quadrant 2. So this is going to be minus. Okay. And that's just cosine U. So that's going to be minus 5/13. So that was really a review problem. Often people do that by making the radius of the circle 13 and doing ratios and just saying that that's at x-coordinate minus 5. That totally works as well. Okay. So anyway you get to that. Alrighty. So now what about the sine of V? Let's call that y. Let's go back to our picture. That's this coordinate. Should be some negative number that fits into this triangle. Okay, so now what we've got is y squared plus 4/5 quantity squared equals 1. I'll skip the algebra. It's a 3, 4, 5 triangle, so you get minus 3/5 because it's in that quadrant 4, so it's negative again because of the quadrant information. Okay, so now what we've got is all four ingredients. Sine V is minus 3/5. Okay, so now we can finally go back to this guy. Copy this down here. Okay, and just assemble the ingredients. So don't do this too early, but it's really crucial that that's part of the process. So cosine U was minus 5/13. Cosine v was given as 4/5. Sorry for the scrolling back and forth. Minus, and then sine u was given as 12/13. Just making sure I get everything right. And sine v is right here. That's minus 3/5. And so I'm going to put that in parentheses because I want to be careful with the minus signs. Okay. So we get minus 20 plus 36 over 65. And so we get a pretty non-obvious answer, 16 over 65 equals. Okay. Now it's a positive number and not super big. Does that make sense? Well, let's look at the picture. Okay. We're going to take this angle, so it's cranking around all the way. I'm going to start with V. Crank around to V. And then I'm going to add in an angle that's a little bit more than 90. Well, if I added 90 to V, I'd crank around to, I'm just going to do it approximately. I'd crank around about here. So it's going to be something like this. Okay, so this is going to be approximately where U plus V ends up by cranking around all the way to V plus another U amount of rotation. And that's got a small positive x coordinate, so the cosine should be small and positive. Makes sense. Okay. Now, same deal, tan of 2u, okay, that, if we knew the tan of u, we'd be good. Because there's a very nice thing that just talks about tan of u. It's actually simpler in some ways than the cosine and sine sum formulas, or double formulas. And, well, that's one thing we haven't calculated yet, but that's pretty easy to do. Tan of u, so let's hold on that for a second. Tan of u, you could either go back to the triangle or just take sine u over cos u. What was the deal there? Sine u was 12/13, cosine u was minus 5/13. 12/13 over minus 5/13, and you get minus 12/5. Okay. And so that means that tan 2u is going to be 2 times minus 12/5 over 1 minus 12/5 squared. Okay, now we just have to be careful with our algebra. So minus 24/5 over 1 minus, now this minus is going to square away, and that's going to be 144 over 25. Put the bottom over a common denominator, and you're going to get minus 119 over 25. And so it's minus 24 over 5. Let me put on their equals. Flip the fraction. Minus signs cancel. And one of the 5's cancels. So I'm going to get minus 24 times 5. So that's 120 over 119. Very close to 1. Okay, let's see if that makes sense. Tan of 2u. So let's go back to here. Okay, so u was 90 plus stuff. 2u is going to be, okay, I'm going to take that much rotation, and then again 90 plus stuff. I think u is going to be somewhere around here. Hey, that's a line with approximately slope 1. So it makes sense. Okay. Okay, that's it.